Okay, here we go. Day one of the Math 136 final exam, review A. Problem number one, we have a complex fraction here. The thing we want to remember when we have a fraction like this is really a division problem. The top fraction divided by the bottom fraction. Remember that when we divide two fractions, what we do is we multiply by the reciprocal of the denominator. So I'm going to take that top fraction, write it as is. I'm going to change this from division to multiplication and flip that bottom fraction so that the x squared minus 16 is on top and 4x is on the bottom. When I multiply, I go straight across the top and straight across the bottom. However, rather than distribute those, I just want to write them as a factored product because we are going to further try to simplify this. And we simplify by canceling common factors. So what I notice right away is the top of that is the difference of two squares. So I can factor that. And then once everything is fully factored, I see that this x minus 4 and x minus 4, those two can cancel each other out. So our simplified result would be this. There's our simplified fraction. Number two, we have a rational equation here. So we have to remember to keep in mind there's a slightly different procedure for simplifying versus solving. On solving, this is when we want to be canceling our denominators. We need to get rid of them so that we can solve. Before we can decide how to cancel out these denominators, you do want to factor each one. So this one, again, factors difference of two squares. And when I see that, now that I look at all three denominators I have up here, I can see that the least common denominator for these three terms would be x minus 3, x plus 3. What this means is that I want to multiply that entire expression, that entire equation, by x plus 3, x minus 3. So I'm going to put parentheses around this. I'm going to multiply every piece by that expression. I'm going to go ahead and write this out long ways. You might see this. You might not need to write out this next step that I'm going to show you, but I really want you to see what's going on here. So I'm going to multiply this first term by x minus 3, x plus 3. And then that equals, there's my second term. Also going to multiply that by x minus 3, x plus 3. And then I have my last term. Multiply that by x minus 3, x plus 3. Sometimes I get the question here, we multiply the top by that or the bottom by that? Well, x minus 3, x plus 3, that's behaving like a whole number here. It is not a fraction. So that means we could write it as a fraction over 1, and maybe that helps you see how it lines up better. It's not that we're multiplying only the top by it. We are, but it's because it's a whole number. There is no bottom there. So now we can do all kinds of canceling. Here, x minus 3 and x plus 3 cancels, and what's left behind is 4x minus 5. Next up, the x plus 3's cancel, so what's left behind is 2 times x minus 3. And then finally, the x minus 3's cancel, so what's left is minus 7, x plus 3. Once we get rid of those fractions, this is a much easier equation to solve. So we'll go ahead and distribute. Both terms distributed here and distributed there. Then we're going to combine our like terms. Over here on the right, we have 2x minus 7x. Watch your sign. That's minus 5x. And negative 6 minus 21 would be minus 27. Then we want to start gathering up our like terms. So I'm going to move this 5x over to the left. And I think in the same step, I'm going to go ahead and move the 5 over to the right. So what we end up with at that point, here we have 9x. These cancel each other. Equals, don't lose your equal sign. Here they cancel. And negative 27 plus 5 is negative 22. Then we divide both sides by 9. And we have our result, x equals negative 22 over 9. Since we did start with a rational equation, the last thing we want to think about before we finish this problem is, does this result make any of our denominators equal 0. And I can tell by looking at these denominators, the domain of these expressions, x cannot be 3 or -3. Since this is not 3 or -3, it is not going to make our denominator 0. So there is our result. Next up, this is a word problem. This is what we call a mixture problem because we are mixing two things together to make a final product. In this case, we are mixing peanuts and walnuts to make some version of mixed nuts. Okay, the peanuts, let's call that X. We don't know how many peanuts we're going to have, but we'll say X pounds. And it tells us right here that the peanuts cost $1.46 per pound. We don't know how many walnuts we're going to have yet. That's part of the question. But what we do know is we're going to end up with 100 pounds of mixed nuts. So when we're talking about the amount of walnuts, if we know the total and we have a representation for the amount of peanuts, the walnuts has to be our total minus the amount of peanuts. And then the walnuts, it does tell us cost $1.94 per pound. And the mixed nuts, oops, I got that, sorry, back up. I read ahead. The walnuts are $2.66 a pound. And the mixture is $1.94 a pound. So what we're going to do, we're going to set up an equation here. Peanuts plus walnuts equals our mixture. And for each one of those terms, we are going to multiply the amount, the number of peanuts times the cost. So there's our expression for our peanuts plus our walnuts, the amount times the cost. And that has to equal the mixed nuts, the amount times the cost. Once we have our equation, hopefully that's not too bad of a solve. We have 1.46 times x. I will distribute here. So we get 266 minus 2.66x. And over here we multiply 194. Let's combine these like terms we have here. Grab my calculator. 1.46 minus 2.66 is, we have negative 1.2x. We'll subtract that 266. And what is that? 194 minus 266 is negative 72. Divide both sides by negative 1.2. And that we end up with 72 divided by negative 1.2 is 60. There's our answer for x. So x is equal to 60. And let's label it. What was that? We got it right here. X was the amount of peanuts. So 60 pounds of peanuts is what we want to put in our mixture. And the question was how much of each? So we also want to calculate 100 minus x, which would be 100 minus 60 or 40 pounds of walnuts. Okay, number 4, we have a 3-part inequality here. So our goal is to leave x in the middle and move everything else out away from the middle. I'm just going to copy it down here so we can work on it together. So first thing we want to do is get rid of that 8 in the denominator. So I'm going to multiply 8 times 8. If I do that, I need to do it on the left and on the right. So 8 times negative 4. Oops, not less than or equal to, just less than. In the middle, the 8's cancel. So we're getting there, 3x plus 1. And negative 2 times 8, negative 16. Next up, I'm going to subtract 1 on the left and on the right. So I have negative 33 and negative 17. And finally, divide by 3. On the left, negative 33 divided by 3, that does simplify to a whole number. On the right, negative 17 over 3 We just leave that as it is. So this is our inequality answer, but the directions ask for interval notation. So this is going to be an interval that begins at -11 and continues to -17/3, square bracket on the 17/3 because of that less than or equal to symbol. And number 5, now we have an inequality with an absolute value. Absolute value and inequalities, we handle absolute value less than in a certain way and absolute value greater than in a different way. This is a greater than. Regardless of which type of inequality we have, the first step we want is to isolate the absolute value. So the first thing I'm going to do is subtract 3 from both sides. And then I end up with absolute value of x minus 7 greater than or equal to 3. You cannot just throw away those absolute value bars and ignore them. Remember, absolute value bars are important. They take away the sign. They tell us distance, but not direction. So when we have greater than, what we have to do is we have to rewrite that as 2 pieces. Either x minus 7 is greater than or equal to 3, or x minus 7 is less than or equal to -3. That's because when we get that greater than, we know something is more than a certain distance away. That means it's either got to be over here in the negatives or up here in the positives. So that's why we get 2 separate inequality statements. Greater than is the 2 tails. Once we get to this point, it's an easy solve from here. Either x has to be greater than or equal to 10, or x has to be less than or equal to 4. Now, I wrote these kind of in reverse order, maybe. When we write our interval notation, we would usually write this one first. Not usually, we would write this one first. X less than or equal to 4, that is from -infinity to 4, square bracket. Okay, those are all the values less than or equal to 4. And with that, we also want to include all the values greater than or equal to 10. So there is our answer in interval notation.